What exists outside the universe? The answer might seem strange at first, but it's absolutely fascinating. Nothing. And when we say nothing, it's not an empty space waiting to be filled, nor a place where something can emerge. It's not the kind of nothing we're used to thinking about. It is simply non-existence. Because the universe, by definition, is everything. There is no outside. There is no beyond. The very concept of an outside doesn't make sense when we talk about the universe. Now, let's refine this understanding even further. What can we, as human beings, actually observe of this universe? Everything we can see, detect, or measure is within what we call the observable universe. It's our window into the cosmos, limited by the distance light has been able to travel since the beginning of it all, the Big Bang. For now, we remain here, looking into this vastness that is at once everything and nothing, where our eyes and instruments can only reach a small fraction of this unimaginable whole. Now, let's explore what this observable universe really means. When we talk about the universe, we're referring to everything that exists. But the universe that we can actually see, study, and understand is just a small part of that whole. This is the observable universe, a kind of cosmic bubble around us. The Big Bang happened about 13.7 billion years ago. This means that light, traveling at the impressive speed of 300,000 kilometers per second, has had all that time to spread out. But here's the fascinating part. Due to the continuous expansion of the universe, the maximum distance we can observe today is much greater than 13.7 billion light-years. In fact, it extends an incredible 40 billion light-years. Within this 40 billion light-year radius lies everything we can detect, like galaxies, stars, planets, and the radiation that tells the story of the cosmos. It's a vastness incomprehensible to the human mind. But beyond this boundary, there is an unexplored darkness where light has not yet had time to reach us. This observable universe is like a capsule of time and space, containing everything we know, while also reminding us that there is much more beyond, invisible, still out of our reach. One of the most surprising discoveries of modern science is that the universe is not static. It is in constant expansion. Galaxies are moving away from each other, driven by an invisible force that stretches the very fabric of the universe. This expansion is a fascinating phenomenon. Think about it, the space between galaxies is not just increasing, it's being created. It's as if the universe is constantly adding new points between each galaxy, pushing them farther apart. And this expansion isn't slow. It's so rapid that in some regions of the cosmos, space is expanding faster than light itself can travel. This leads to a consequence. There are galaxies moving away from us at such a speed that, eventually, they will become invisible. They will exit our observable universe, not because they've disappeared, but because the space between us and them has expanded so rapidly that the light they emit will never reach us again. The universe is constantly changing, evolving, and in its endless expansion, it's creating distances so vast that even light, which seems to be the fastest thing we know in the universe, cannot keep up. The cosmos, in its infinity, is always one step ahead, always expanding beyond what we can see. What could exist outside that vast sphere we call the observable universe? The most likely answer is both simple and intriguing, more of the same. Beyond this invisible boundary, it's believed that there are more galaxies, stars, and cosmic structures similar to those we see within our visible universe. These unexplored realms of the cosmos are not different from what we already know, but they remain hidden from us because the light they emit hasn't had time to reach us yet, or perhaps never will, due to the lifespan of humanity as a whole and the continuous expansion of the universe. This expansion of the universe, which continuously pushes these galaxies out of our reach, is driven by the battle between two fundamental forces, gravity and dark energy. Gravity, always pulling, trying to bring everything back together, and dark energy, a force that accelerates the expansion of the universe, pushing everything apart. The geometry of the universe, the way it curves and stretches, is shaped by this constant struggle. If gravity were to win, the universe could eventually slow down, even contract, and ultimately collapse in on itself in a catastrophic event known as the Big Crunch, where all matter and energy would be crushed back into an infinitely small point. On the other hand, if dark energy continues to dominate, the future would be completely different. In this case, the universe would expand forever. The galaxies, which are already moving away from each other, would continue this process until they're eventually so far away that they disappear from our field of view, leaving increasingly larger empty spaces, astronomically speaking. But there is a third possible scenario, a flat universe. In this delicate balance, gravity and dark energy counteract each other in such a way that the universe's expansion continues, but at an increasingly slower pace. There's no final collapse, but also no runaway expansion. The universe would remain in a state of constant, eternal expansion, slowing down but never stopping completely. These scenarios paint a cosmic future that could range from total collapse, to infinite expansion, to perpetual equilibrium. Each possibility is like an unfinished story, waiting to be written by the forces of our universe. When we think about the shape of the universe, the first image that might come to mind is that of a vast, flat space extending infinitely in all directions. And, indeed, current observations suggest that the universe, on a large scale, appears to be flat. But this apparent simplicity might be misleading, a conclusion based only on what we've been able to observe so far. The true geometry of the universe could be much more complex than we imagine. Think of a Pringles potato chip or a cosmic doughnut. These curious metaphors help illustrate how the universe might have curvatures and shapes that challenge our understanding. If the universe isn't perfectly flat, it could curve in ways that create unexpected structures, folding in on itself like a three-dimensional surface in a higher dimensional space. This hidden geometry could mean that if we traveled far enough in one direction, we might theoretically end up back at the starting point, like walking around the surface of a spherical planet. Or perhaps the universe curves in even stranger ways, where the laws of physics as we know them would behave in surprising ways. So, while the idea of a flat universe is a convenient hypothesis, it might only be a simplification of a much more complex reality. In the end, the true shape of the cosmos is a mystery we are only beginning to unravel, hiding secrets that could revolutionize our understanding of everything that exists. What lies beyond our visual reach may hold the keys to unraveling the future of the universe as a whole. Those places we cannot yet observe might be evolving in ways that offer us clues about the ultimate fate of everything we know. It could be there that the answers to the deepest questions of cosmology reside, waiting to be discovered when, and if, our methods of observation and understanding can reach them. In the end, what exists outside the observable universe is not just a matter of nothing, but an invitation for you to join us on this journey of exploration and discovery. Subscribe to the channel, and together, let's uncover what the future of the cosmos truly holds for us.